such inefficiencies is there because of the wastage and increase of operational costs, okay, which will impact the sustainability and profitability of the farm. Now, I'll move on to a design process. The first one is me. I'll be doing two things in this project. First one is sensors integration and designing the DC power system for powering up the whole sensors. I'll be using 5 different kind of sensors and with a DC fan for ventilation. Now, first one, DHT level, temperature and humidity. Secondly, PRR motion sensors to detect motion. Thirdly, LDR sensors to detect light intensity. And fourthly, an MQ135 gas sensors to detect any hazardous gas in the area. And then we have also a weight load sensor, which is called HX711. So a DC fan is there to do a simple ventilation system when there's a hazardous gas detector.Moving on to power system, I mainly uses an LM2556, which is a DC-DC converter to convert a 12-volt DC battery to a 5-volt DC battery for all the microprocessors and sensors. And then a Q switch is there to turn off the system. jack is there the battery from the DC-DC converter. And then there's also, of course, a 12-volt DC still as a battery and some ribbons cable for connections.
Hi everyone, my name is Chu Jingyuan. My task is to perform acoustic monitoring on classifying different chicken sounds. There are 3 main steps to perform this task, and the first one is transform the audio files into spectrograms. After that, I use the spectrograms to train the dataset using the TensorFlow technology. The last one is the real-time sound classification. This is the first step, transform the audio files to spectrograms. And this is the one of the example of the spectrograms. You can see this is the chirping spectrogram with the frequency around 4000 Hz. The x-axis is the time domain and the y-axis is the frequency domain. After that, I use all the datasets to train my model. This is the file directory, and the first one is the train, and the second is the validation. There are 5 categories. As you can see, the first one is chick, roaster, farm noise, speech, and silence. This is the final step, which is real-time sound classification. This is the GUI. As you can see, the result is detected like silence, chick chirping, chicken farm noise, rooster crowing with the confidence level. As you can see, the last one is the speech with the confidence level. After the user press the exit program button, there's a dialog will display. After the user press the exit program button, then the program will be terminated. And this is the output, which is also shown in terminal.
Hi, my name is Samuel Benjamin Marengo, and for my part, I developed a remote control door that can be operated using Wi-Fi and the blinker. Here's a sample code that I developed in the Arduino IDE, where you have two sets of code, one for toggling the safety switch of the door, and another one for toggling the actual door. Here is the sample parameter that I have inputted inside the blinker. So you have to make it correlate with the Arduino IDE code that you developed.
Hi, my name is Junkan, and what I'm doing is the AI-powered chicken detection using the YOLO V8 and the OpenCV. The YOLO V8 is for the object detection, and we have the GUI, which is can select the video source from the cameras or the files. Annotate the videos and detect the result. Key features of this thing is the camera detections, which can scan on and list the connected cameras automatically. You can see it here. Here is the quick scanner result for the cameras. And next we have the file sections, which allow the user to go to files, which MP4 and SD. And here is the file section. And next, for the real-time processing, we can annotate the videos with the frame per second and number of chicken. And here is the UI, which is user-friendly. Next, here is the chicken detection result. You can see the background image. We have the 4 chicken being detected, let's show it here. And the frame per second of the result is 31.2. Next. This is
I integrated with Woon so that all the environmental data can be shown on the web dashboard for users to view. So here we have the simple login page, and this login uses authentication from Google Firebase, which Woon has talked about. And here for the integration of the AI chicken count as well as the sound detection, we have showing the active number of chickens that are counted in the farm and the active sound that is being recorded as well as the confidence. So this is the main web dashboard, and from this web dashboard users can select a date range to view the data that has been collected. And here, from the data that has been collected, the temperature, humidity and air quality, which would be the ammonia levels, are shown. So very easy to understand, the green colors and the text saying good, optimal, or if it is in bad condition, then poor. As well as analysis is done on past data that has been.
So this is the microprocessor of ESP8266, and then here is the microprocessor of ESP32, and then some of the sensors they have attached here. So first one is the DHT11 temperature sensors, and in here we have MQ135 gas sensors, and here we have an LDR sensors, okay, and also below we have an motion detector sensors, and here is some little a little DC 12-volt fan for demonstration purposes of the ventilations, and here is my DC converter, all right, and then here are some of the kill switch, and finally we have a dash cam for the chicken counting by using the YOLO by one of our teammates for monitoring purposes, okay. And lastly, here is the weight sensor of HX711, and also the automated door is right in front of the gate, okay, of the frame. So actually the frame is actually represents the farm area. So this is a structures to show on the systems inside the farm. So now I will pass it to my teammate Samuel to explain his door.
Hi, my name is Samuel. To start, I will start by showing the remote control, where you have one toggle button for the safety lock and one toggle button for the actual door. So I will show a little demo where you can toggle to open the safety lock, and then you can toggle to open the door. I will now show another small demo of closing the door and closing the safety lock.
Hi everyone, my name is Chu Jingyuan. My task is acoustic monitoring on classifying different chicken sounds. The aim of this task is to enhance understanding of poultry behavior and farm conditions, enabling efficient monitoring and providing valuable data for farm management. Without wasting the time, I'm going to start my program. When I'm not talking, so silence will be detected. When I'm talking now, so you can see the speech is detected. Now I'm going to play some chicken sounds. Chick chirping sound. Chicken farm noise. Rooster crowing. When I press the exit program button and I press OK, the whole program will be terminated. You can see this is the terminal of my program. All the output is
for the chicken. You can see here, this shows that the cameras we can select, and if we have more than one cameras, we can select more cameras at here. I will show for the video processing. So you can see, you can select the video. You can see it can detect the birds, which is the chicken, detect and classifies birds, and you can see that the frame per second of the processing the image is very slow because of the processing image, and you can see this total out of 2 birds and which is counting the numbers of the chickens. And that's all for the videos. Thank you.